So let's see what's in that. Try not to show the customers stuff. Oh, this is so well packed I can't get in it. Oh right, 7780 805 with some bits. Oh well, at one set a week, these are going to be some weeks, aren't they? What else have we got? A microphone. Another microphone. So 2 radios and 2 microphones. I was beginning to think there was about 5 sets in there. Well, I think we'll start with the mic that doesn't say anything on it, so chances are that actually works. And the radio that is more likely to work. I was always taught by my dear late mother that you always do the hard job first, but I think with these we'll start with what could be the easier one. Because these mics are like gold dust, aren't they? Well, at least it's got a plug on it and it's in one piece, and there we go. So we need a thingy connector. I think we've got one up here. I'll just check the polarity of this. So we'll check inner. The one with the stripe is the inner. Now our power supply is current limited. I'll make sure that's really down in case the polarity is wrong. So this is the 77805 UK. And the other isn't. The other one is the it's the 77805 UK, but it's the one which has a real channel switch. I seem to think that we've got here the one which has a rotary encoder. Interesting. So I used to think we had the D version and the UK version, but perhaps not. So we'll plug it into the test equipment. So Midland 77805 UK, and I'll put better one, only because it hasn't got a part tape to it. So we'll switch on. Starts off on channel 9, which is definitely going to be the one with the rotary shaft encoder. So you can hear we've got the test signal from the signal generator. I'll make sure we're plugged into the test equipment on the speaker instead of the one in the mic. I did that initially so we knew that the mic actually worked. So we're now on the test equipment. So at the moment we've got 0.3 microvolts on the signal generator. Let's see what we need to get 12 decibel cyanide. Well, there's about 12. So it's 0.76 microvolts for 12 dB cyanide. So it could be worse. Now let's look at transmit. Are we on low power? That transmit switch isn't very nice on this one either. It's kind of sticky. I'll have to take that apart. Not that we mend mics, but it looks like we're going to. So the switch was in the low power position, and in low power, we'll go back to low power. It's doing on low power 150 milli. Oh no, 200 milliwatts. Just make sure I'm not lying to you. Yes, 200 milliwatts. Should be 400 milliwatts. That should adjust. I'm sure it's adjustable on these. So we'll go to the 4 watt range. The range is doing 2.7 watts, as you can see. That would be 5, that's 4, that's 3, so that's 2.7. So where the deviation is. Wallow, 1 2 1 2 1 2. Oh, why is that? 1 2 1 2 testing 1 2. Are we off? We're off. Wallow. It's doing 2.1. So it just needs to pop up a bit on that. So I'll open this up. Remember, there's no speaker in these, so although these do come up with the body only, and you can use them with an ordinary mic and not the speaker mic, you would then have to plug in an extension speaker to use it as a mobile setting in your car. Now the customer did say, did I want the actual Port-A-Pak? I said only if you've got battery issues with it. Did I want the power lead? So he does have everything. He's probably got the area locked in his safe, because you know what they're like, don't you? You know, they sell for twice as much as these sets do. So the phase lock loop chip is the C512 whatever, I can't read because it's under there, rather than the LC7137, which is going to be on that other one which we've got. So let's just go and do transmit just before we transmit frequency, because we may as well. It's clearly off frequency, and it is. So if we go over to the frequency counter, it should be 2779125 on channel 20. It's 2779023. So we can do that very quickly by altering the reference crystal, hopefully. No, that's going down. That's gone miles up. We'll get it eventually. That's ideal, just slightly high. So that's good. So I'm going to print off a copy of the service manual and we'll take it from there. Okay, here goes. So I've printed off the wrong circuit diagram and the wrong service manual because we don't have the right one. So we're going to have to make up a bit of this. I know I've done these before, but so we're in a position where there's a lot of building work taking place and most of the stuff is in storage, so that's why we're trying to wind down this operation really till the end of the year. So in fact this room's got to have a a new window, so everything's going to have to come out apart from this actual bench. So your picture-in-picture camera's going to disappear in the next few days. Right, so if we look at the transmit strip on this, now first of all we need to bring up the transmit power, and it's adjustable on these with RV2, and RV2 is there, with RV2 is there. So if we key up and bring that up to maximum, we've now got 3.4 watts. Now we can go through the tuning, see whether we can improve on that. So that's now peak. That's peak. We're about 3.5. That's now peak. And that's now peak. I'm going to twiddle that. It's probably on the receiver. Yeah, it will be. So, and that doesn't have a core, which is, I think, normal on these. So, we're now at about 3.6 watts. And we're at 13.7 volts. So what's it doing on low power? Low power isn't adjustable. We're still doing 200 milliwatts. But it's not a legal requirement anymore. It was once. It's supposed to be 10 decibel attenuation, so if it's 4 watts, supposedly it's supposed to be 0.4 of a watt, but it's doing 200 milliwatts. So that's that. So we now want this to show four bars on high power and 1 bar on low power, and it's doing exactly that, but I'm not sure which trimmer it is. So because of that, we're just going to fiddle. I think it could be RV2. It is. And that's how they want it to be. So it just lights the 1 bar. Then when we go to 4 watts, it lights them all. So RV2, we've verified. It's RV4, which is TX power. TX power meter. Now we need to look at deviation. So it just needs to come up a little tiny bit. I can't again remember which one it is. Chances are it's going to be the one down there, but it isn't. Chances are it isn't going to be the one there, but it isn't, and definitely not the one there, but it is. 1, 2, 1, 2. That's now spot on. So we want it as an absolute maximum of 2.5, and it's supposed to be being averaging around 2.2. So that is deviation. So we've got S meter and squelch will be those two. So I think that's where we've got with transmitters. We've done the frequency. We've brought the power up from 2.7 watts to 3.6 watts. Yeah, I think we're there. We really do. So we'll look at receive. First of all, we will do the detector coil. So we know that these are TX, 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 TX. So the detector coil is going to be the one on its own near the FM subsystem chip, so it's going to be that one. And ideally, I'll find my black phosphor bronze twagger. So we want a big signal. I'm going to put S9 equivalent of 100 microvolts on. We'll turn the volume till we get a kind of sensible trace. just connected across the speaker terminals. There's nothing clever about the oscilloscope. It's just looking at this audio. So let's see whether we've got maximum. We hadn't quite, so that's brought it up a fraction. So I'll just make a note that is detector, or demodulation, or whatever you want to call it. Now we'll go over to the synad meter. Turn the oscilloscope off. So we want about 4 dB on there, so what we're doing with the tuning isn't saturating the receiver. If you have a good signal like that, you can't see it. You can't see anything change because the radio is saturated. So we'll start at where we believe to be the front end, probably that coil I fiddled with. Just brought it up a fraction. I'm going to now move the attenuator back to 4. Wow. I'll do those 2 again. Because sometimes it can be interactive. Okay. Well, that's all there is. We've done the detector. It's the one with the chip, so the earlier version with lots of transistors has got more adjustments. So let's get a reading of how many dB it now is. I would say that was 12. So it's now 0.58. From 0.76. And just for your information, for 20 dB it is 1.6 microvolts, and for 10 dB, which is often used, it's about 0.48 microvolts. So that's a good result, and so it is now on frequencies, so that also helps. So we'll go back to that S9 signal of 100 microvolts. Let's show the attenuator. 100 and 0. So on the radio we've got a full set of lights. Well, I want it to be 4 lights, not 5. So it's going to be one of these, and chances are it's going to be that one. And it is. I'm actually right for once. So we'll just have that light there. So that's 3 bars for S9. So we'll get a bigger signal, it's going to light the plus 30. And if we get a smaller one, it will drop down. Okay? So that's RV1 is S meter. Which means that the one left there must be squelch. Right, so what we're going to do is set the squelch to maximum. It's concentric on these, it's the outer ring. We've got that, and I want the squelch to come in when I turn the attenuator to 100 microvolts. 1, 3, 10, 30, 100. It's spot on. Absolutely spot on. But if it wasn't, I'll just prove it to you. I'll set the thing to 30 microvolts. I will prove it to you. Okay, well, that's not really having much effect. I will just check, but that is, I am sure is squelch adjust, because there's nothing else left. Well, that's really ineffective. As it happens, it's working right. 100 microvolts, 30 microvolts. Let's look at the sensitivity. We'll put the squelch to threshold position. The signal generator switched off. Switch the signal generator back on. It's parked at 0.3 of a microvolt, and it's come straight in, which is really good. So I'm losing it at 0.06 of a microvolt, and it's coming in at. Now that's not good. So I wonder if that's. I wonder if this does more the sensitive end. No, it doesn't seem to do anything. Let's try that test again. Set threshold. Signal drainage back on. So let's see where it's coming in. 0.7 of a microvolt. And leaving it 0.06, so quite a wide range of hysteresis. Now I'm going to just look at this PTT switch because it's having a tendency to stick. It probably wants cleaning or some kind of plastic grease putting on. So turn picture in picture off. And we'll just open this up. I've got to go and do a shopping job for an elderly lady from church. She's in her 90s. And she lives 8.8 miles away. And she likes me to shop at the most expensive shop there is. I don't know why that is. As a Yorkshireman, I may be living in Lincolnshire, but I'm a Yorkshireman. The whole thing is to never do with more what can be done with less. And it's not like she's loaded with money, because she's not. So I'm going to take the PTT, if we can. Yeah. I'm just going to slip that out and do some scratching just there. Just see whether we can buff that up in some way, and I'll do that behind the scenes. So pause the video. Okay, so moving back onto this, I've took that mic apart, put it back together. What's happened is that at some point on the PTT bar, it's had some chemical which has kind of melted it, so it makes it a bit sticky. It's not sticking as such, but it's just a bit nasty. But I used to have some Perspex polish and it might have worked with it, but I'm not going to file it down or touch it because these, as you know, these mics are pretty irreplaceable. I don't want to mess it up. So the final thing I want to do, we'll just go put picture in picture back on, is what did we say, 3.6 watts we're doing. Just check that on the meter. Yes, 3.6 watts. So let's just see at what point. I'm just going to see what it's doing at 14.4 volts. That's where my own car charges. It's actually 4.05, so it'll do 4 watts on a car that's charging normally. So that seems better than it could have been. So pop that back down to 13.8. To be honest, to be fair, I got it at 13.6, and we'll see what it is at 13.8. Yeah, it's about 3.7 watts at 13.8. So, yeah, it's not bad. So, I'll just plug an aerial in, and then we'll do a scratchy corner test with Mr. Chippy. So the base aerial here, I keep saying, is a Antron 99 type without the ground plane optional kit, and it's mounted at gutter height, which is this is a single story building. So it's nothing clever, and that's why we do this, so that it's not elitist. We don't do elitist. So let's have a look. 19 Roger. Okay, so that's where we are with it. We're still an external speaker. We'll now plug it into the internal speaker, as in the one built into the microphone. And there we are. So there we have it. That's now serviced. The receiver's been improved. The transmitter's been improved. I've got a bit more deviation as well to bring it up to where it should be. So I did this first because his second mic, which he sent with his other radio, is not transmitting. And it just means I can use this as a test bed to fix his other mic before working on the radio that doesn't work. I don't think it transmits. So we've got a mic that doesn't transmit. We've got a radio that doesn't transmit. So that's why I'll sort his mic out on this one. There's a bit of muck in that speaker grill. Can I get it out with that bit of paper? Probably not. So there we have it. The later version of the Midland 77805 UK. I think these were as late as 1991 or something like that. So it's the one which doesn't say channel 9, whereas the earlier version, which we're going to do next, does say channel 9 because it uses a normal channel switch instead of a rotary shaft encoder. Thanks for watching.